today we're here to talk about bonding. I mean, that's kind of Peplink's claim to fame.
It really is, and it's one of those things that's kind of interesting because I didn't like I got into Peplink because of their ability to do multi-WAN load balancing. So we were using it as a DNS server, and it was like I had a small business server, and I could have like my broadband, my cable broadband, and my DSL broadband circuits with a public IP, and then I had NS1 dot I forget what the company name was back in the day, but peterscomputercompany.com and then ns2.peterscomputercompany.com and I was load balancing incoming sessions on this Peplink Balance 300, and it was the coolest thing in the world to be able to basically have mail.peterscompany.com and have it just work without having to worry about mail one and mail two or having multiple UR host names for my VPN or remote access and things like that. And when Peplink started playing around with introducing bonding, it changed everything. The ability to aggregate those WAN connections between my sites meant that I no longer needed expensive MPLS to have an SLA, a high quality guaranteed circuit between my sites.
Mm-hmm.
And I loved it so much that if you're one of my OGs, if you bought a 380 from me, I did the install for free. It was like I was like, man, like I'll drive all over the country installing these 380s. And the idea was simple. It was like, man, we could replace your MPLS circuit with two bonded fiber lines for less than the cost of your MPLS circuit. And so my old sales pitch was with Peplink SpeedFusion, I could offer somebody more, better, increased reliability for less money, which never happened. Everything always had this, well, I can give you more, but it's going to cost more. And this was the first time we could say, I can give you more. And actually, when you compare it to the alternative solutions, we're less expensive. And it was an awesome sales pitch to be able to do that.
Yep. And it's not smoke and mirrors, it's real.
No, exactly. It wasn't like the sales guy saying, hey, this is awesome. It was like, no, this is really awesome. And once I let a customer see it, everything changed. They were skeptical. Well, it's that whole saying, right? No one gets fired for buying Cisco. Well, it was like, yeah, but this works, and it worked well. And so, anyways, so what we're going to do is we're going to talk about bonding and kind of go over some of the myths around bonding, as well as some of what other people are doing, and then talk about the Peplink bonding technologies. And so this is sort of, we've had lots of SpeedFusion videos and things like that. This video is just bringing it up to date, but also talking about some of the history and why some of these things are important.
Yeah. Let's dive in.
Yeah, let's dive in. So the most common VPN protocol that's used out there right now is IPsec and IPsec bonding. And the idea is each session gets load balanced across multiple WANs that are all creating multiple IPsec tunnels with each other. This is commonly seen in your modern SD-WAN solutions, or they'll tell you they picked the best, or they'll tell you they're bonding. But what they're really doing is creating two or more IPsec tunnels, then load balancing the sessions across those, or actually round robining the sessions across those connections. And that in theory, if you had a 1 gig circuit and another 1 gig circuit and you're load balancing, you're going to see 2 gigs of throughput. It in theory works based on that session bonding. But the problem is you're still only using one internet connection per session at a time. And if that one internet connection fails, the session then has to move over to the other IPsec tunnel or the other internet connections that are established. And so, and then they have limitations. They only work well when you're combining similar circuits. So, two broadband 500 meg circuits. Well, that way, if you're load balancing them, you're getting what you would perceive as one circuit. And then the other thing is you're only going to get the maximum throughput of any individual circuit minus the overhead. So if you have two 1 gig circuits and you really want to do that backup connection at the end of the night and use up 1.8 or 1.9 gigabits of throughput, You won't be able to do that in these scenarios. You'd have to have multiple sessions to be able to utilize that. And so it does increase reliability of your connection. It does give you what people would call SD-WAN, but it's not what we do. And I'll leave it at that, because I think what we do is awesome.
Yeah, and I think this is what you see. There's a lot of players in the SD-WAN space, right? And there's some very big names in the industry that have been doing this for a while. And I think this summarizes what most of them are doing at a basic level. It's useful, it's helpful, right? But it's not what Peplink does. It does not achieve the level of efficiency and application protection that we're able to do. But it's better than traditional IPsec. I'll say that, I guess.
Exactly. Okay.
I think the big downfall, like you mentioned the throughput, there's some caveats to it, but I think fundamentally what's happening there is any single application is going to, again, live and die by the quality of that a single WAN. And so,
yep.
You're only going to get the speed of a single WAN, and if that WAN is degraded but still functional, so is your application in most cases. And so, again, it's useful, but it's just not what we do.
Exactly. And another common bonding method is LACP bonding. LACP bonding is basically creating interfaces and then using LACP protocol, link aggregation connection protocol, to bond those together. And once again, this would in theory increase throughput if you had two 1 gig circuits that were operating with similar latencies and similar connection capabilities. You would be able to then aggregate those together.
Yeah, I think the biggest drawback here is it requires identical circuits, basically.
Correct. Yeah. The biggest downside is it's going to require the similar circuits, and it's very latency and packet loss sensitive. Mm-hmm. If you have too much packet loss or too much latency, it can break the bond, creating an unreliable solution for variable circuits like Starlink or 5G or even some broadband. I mean, if you've got a bad broadband circuit, it can really cause that to flip flop, creating a instability in that circuit. And I think most companies have really gone towards the IPsec bonding, and kind of moved away from LACP or protocol bonding, but there are limitations on it.
Yeah, you see this still commonly, like with Metro Ethernet providers, where they're going to give you two physical circuits, and then they're going to use basically switches on each side to bond those two identical circuits. And that's a good use case for it, but it's very limited in terms of what connections you can bring to it. It's kind of more of a back-end technology than something that
it's a carrier or handoff. And the other thing too is it's not scalable. You have to be on their platform to make it work. Like you can't just take a 5G chipset and throw it in there, or Starlink and throw it in there and add it to the mix.
Yep, exactly.
So SpeedFusion bonding, Peplink said, okay, well, LACP doesn't work. IPsec bonding isn't scalable. How do we make a bonding solution that will work on any internet connection from any provider without the need for specialized carrier connectivity, and creates dynamic capabilities to handle variable loads? So 4G, 5G, cable modems, DSL modems, Ethernet, Metro Ethernet, private networks, Starlink. How can I create a protocol, a bonding protocol that allows me to use any internet connection? And Peplink invented bandwidth bonding, and my life changed forever. And I mean that in the utmost sense of that. I mean, West Networks and our company, the ability to solve problems dynamically changed when Peplink introduced SpeedFusion bonding, and it's only gotten better every single year.
I just remember, I can't remember even what the year was, but I remember the customer that really pushed this, and I can't say names because they're a government entity, but they wanted to bond two VSAT connections. They had, VSAT connections have a pretty finite bandwidth at their terminals, and they had two of them, and they had one application that needed more bandwidth than any one could provide. So these other technologies that we've talked about just weren't useful for them. And that really was what pushed our engineers to really try and tackle this challenge in the first place, was just how do we make these two satellites come together and give you more bandwidth than any one of them could? And we were able to achieve it. Our engineers tackled the problem and dug in, and yeah, then so was born SpeedFusion. We didn't call it that yet, but yeah, it came out of an absolute need from a pretty important customer.
And then I took that with a 380 and actually used cell modems and then bonded cell modems for the first 2D mammography image transmissions in rural Louisiana.
Yeah,
And so, yeah, it was, I mean, that was my first real SpeedFusion project, initiated by Jerry McLarty over at LSU. And it was, like game changing for the ability to actually increase bandwidth and transmit those images in real time, which was just not able to be done previously.
yeah, it's like so many things that Peplink has done over the years. Once, the engineers create new solutions for problems that get brought to them, and then the cat's out of the bag at that point. Our user base, our partner base like you, Peter, are so creative and have so many other challenges, and you start applying them in ways that maybe we didn't even foresee at first. And out comes this mobile mammography solution from something that we really didn't frankly intend it to be used that way. But lo and behold, we keep working on it and improving it, and yeah, it solves that problem too. And it's kind of
Yeah,
classic Peplink story over and over
it
again.
is. And one of our early case studies around bandwidth bonding is actually the town of Tonawanda, New York. And this was a neat case study because we actually converted an entire town from a private MPLS network over to a commodity internet bonded solution layer 2. So we were doing layer 2 across the network, and basically they had their VLANs for their police and their fire and their water works and different things like that with commodity internet. And so they did an evaluation of the cost of having a 100 megabits per second MPLS network between all their sites, and the cost of just buying two 50 meg broadband circuits across all their sites. And we were able to save them around $86,000 a year in internet costs, which this was years and years ago, which was a big deal for them. But that was less than the entire capital cost to buy all the Peplink gear. So for less than the cost to buy all the gear, they were saving, they had, I mean, it was literally a 1 year or less than 1 year ROI. And they were able to increase that reliability. And the IT guy at the time, this guy, Andrew, really challenged Peplink and the technology to make sure the layer 2 worked and the VLANs were able to span across those networks. And he tested high availability. And so we were able to really fine tune bonding at that during a critical moment, and kind of the evolution of the internet and broadband and high speed circuits were coming out, and making this something that everybody could use. And it was an awesome to be part of, but also to see what the Peplink engineers were able to pull off. I mean, the problems they could solve with just some software. We didn't have to buy new hardware. We just tweaked the code and they were able to make it work.
And I think the underlying all of this is really the difference here is we're doing bonding differently, and we're sending, instead of sessions down different links, we're taking the individual packets and
Packets,
redistributing those.
hence the next tab.
And
Yeah,
so
so
it's just, it sounds simple, right? It sounds like, okay, anybody could do that. And it turns out that's complicated. But again, this is the challenge that Peplink's up for, and the trail that we blazed early on. And that's why today we have such a different technology that is able to do so many more things.
I mean, we have, I think Alex was saying it at the Australian summit, but I think we're at what 18 years of bonding experience,
Mhm.
like fine tuning and applications. And you think of like anybody, like even if like Tesla or somebody like that, that's going around getting all this information, this people driving, and they're learning how to drive by watching people drive. Peplink has 18 plus years of experience solving problems around weird WAN situations. And so it just makes us kind of experienced in that capability. And what Travis just said, we do this by doing packet based. So we're not doing session based. We're not doing round robin. We're not doing LACP. We're doing a customized VPN protocol with packet based bonding. This means that we're monitoring those packets as they go across. We're splitting that up and actually using all available circuits with their latencies and jitters and packet loss and individual nuances to each of those circuits, and taking the best of all the internet available. And that's I love being able to say that. Like, oh, you picked the best one. No, no, no. We take the best out of all of them. So if AT&T can give me 10 and T-Mobile can give me 25 and Verizon can give me 15, I've got my 50 megabits of throughput. And sorry, do my math real quick. But the idea is that I'm using every bit of internet that those carriers can provide me. And then there are don't know the right word here, costs associated to it. Like, you know, if T-Mobile's latency is way better than AT&T's, well, the latency is going to go up a little bit to match AT&T's, right? Because we're going to make sure those packets get delivered at the same time. And so, you know, you're not going to have the lowest latency unless you use some of our other technology. But, you know, the idea is you're trading off. And so you're either going to trade off latency or packet loss in exchange for bandwidth, or you're going to trade off bandwidth bandwidth in exchange for packet loss, lower packet loss and latency. And we'll talk about that in a minute. But one of the cool things is one of my good friends, Adam, over in the UK, Agent Adam, bonded 101 internet connections together on an EPX router to create an incredible opportunity for reliability. And if you haven't followed him, he now has his own name. I'm Professor P. He's Agent Adam. And so he's the European version of me. And so he's going to be teaching at our Peplink Tech Summit and telling this story. But he had a mission critical event, and I don't want to, you know, his story is pretty cool, but he had a mission critical event and he needed to get as much internet as he could. And he used synergy mode and virtual WAN and Wi-Fi WAN, and basically created 101 internet connections and bonded them all together to accomplish the mission. And what an amazing testament for the power of the hardware, but also the scalability. And I think that's really, when you're looking at session-based or LACP or IPsec tunnels, you have IP limitations, CGNAT limitations, protocol limitations. Peplink doesn't have those limitations. We built our own protocols from the ground up, making this incredibly resilient across all internet connections. And so basically whatever you can give me as an internet source, I'm going to use that to add to increase reliability or throughput.
Yeah, and I love this because it sounds like this is like some sort of like novelty thing, right? Like, why would you do this? But I love it because, Peter, you've faced some of the biggest names in networking in real world customer scenarios, and you've been introduced to those customers because those vendors had very significant limitations in how far they could scale this concept. And you've brought Peplink in each time and demonstrated that, hey, Peplink works here. We don't have that limitation. We can go way beyond that. And so 101 may sound like a crazy number, but you know, maybe your number's 13, maybe your number's 7, whatever it is, we can hit that number and we can hit those challenges. And over again, SpeedFusion has been demonstrated to be superior at bonding efficiency, bonding speed, and reliability.
Amen. So what is SpeedFusion? SpeedFusion is and I am going to read this because I think this one's important, but SpeedFusion is Peplink's patented system architecture that delivers unbreakable internet connections, enhanced speeds, and seamless jitter-free video conferencing. And so SpeedFusion achieves this by combining end-to-end architecture with core technologies integrated into every Peplink product. So it includes software that allows users to configure, define, prioritize the quality of service to their applications, along with cloud services that are available on demand or through subscription. And I don't normally read slides. I try not to, but I actually love this slide because we are like, SpeedFusion is not an IPsec VPN or just LACP, which we're constantly referred to. And sometimes I have to do, Yeah, we create these tunnels, but we're not. We're from the ground up, patented architecture that is different, and allows us to scale unbelievably more efficiently than other solutions are out there. And what's cool is Peplink, when they see a need, they try to solve that. And so Peplink is end to end. So I've got an HD4 MBX in my car, and then I've got an SDX in my office, and I'm bonding to that SDX. But they realize that not everybody has 40 gigs of internet at their office to be able to add to be a bonding host. And so they offer Peplink SpeedFusion Cloud, and so you can use our Connect service for your own personal environments, or the ability to achieve reliable internet from anywhere in the world.
Yeah, I think the flexibility is something that really brings us into a lot of different projects, because different SD-WAN vendors have different architectures, and they're basically isolated to that architecture. Some of them are very carrier aligned, where they've partnered with carriers to put the debonding or the other side of the bonding appliance in the carrier's network. And for certain scenarios, that's great. But Peplink has this flexibility to do basically any of those architectures and still give you those great outcomes. And so it's, again, we're able to say yes to just about any project, any requirement, because of that flexibility. And so, yeah, SpeedFusion, I agree. I really like that definition too.
Yeah, I just thought it fit really nicely. So we know that bandwidth bonding is not a one size fits all solution. And some customers, and I mentioned this earlier, they go, yes, but latency is critical to me. If I'm doing voice and video applications like this Zoom meeting, I need to make sure that my latency is low, that my jitter is low or non-existent, that I don't have a lot of packet loss. And so Peplink came up with something called WAN smoothing. Smoothing creates a RAID array of your WAN circuits. And so if you've ever played around with RAID arrays for your hard drives, especially back in the day, basically it's a redundant capability. So instead of increasing bandwidth, it increases or decreases latency and jitter by duplicating packets. So because we're packet-based bonding, not session-based, we can split up the packets and fill in gaps where missing. So if I've got, I've got this router's got two AT&T and two T-Mobiles, and I'm bonding those together. So if either of those circuits starts to mess up, the goal is that the bonding is going to fill in those gaps. So the WAN smoothing is going to add parity to be able to fill in if there's packet loss and jitter or latency spikes of the tower. And so it's going to create a nice, clean environment no matter where I go. And so you're sacrificing bandwidth in exchange for latency and reduced jitter, or low latency and reduced jitter.
Yeah, like the RAID example, right? It's a mirrored array, right? We're sending identical copies down each path so that if one of those disks fails, there's no failover time. The other copy's on its way simultaneously, yep. And that's just the difference of latency between the two circuits. So we use the fastest packet every single time. So if you're driving and T-Mobile and AT&T are fluctuating, we don't know who's going to be the fastest for each packet. So we just pick the first one every time, and that results in smoother video, better audio, and ultimately lower packet loss and latency.
Then we have forward error correction. Forward error correction we built for the broadcasters, and this is kind of a middle ground between WAN smoothing and bonding. The idea with forward error correction is for broadcasters that need bandwidth. A lot of times if you're doing like a 720p, you need like 2 to 3 megabits of throughput. If you're doing 1080, you need 4 to 8 megabits of throughput. And so the idea is you need to make sure you have that minimum upload, or a minimum of 4 to 10 megabits of upload throughput for your stream. So you don't want to like have this reduction of bandwidth in exchange for latency, and you don't even care if there is a little bit of latency because you're broadcasting and there's buffering and things like that go on. What you need is to make sure those packets are delivered, and you want to make sure they're delivered well. And so forward error correction uses less overhead than WAN smoothing, reduces jitter by basically adding a smaller amount of parity. So instead of a full duplication of the packet, it just adds parity bits to each of the streams over each of the WANs. And so if there's packet loss, it can fill in the missing pieces that are received on the other WAN. And so it's not a true mirror. It's just a parity bit that fills in those missing pieces that get dropped over cellular and LEO type solutions where you have that packet loss occurring. So it's going to cost a little bit of bandwidth in exchange for less jitter or packet loss, but not necessarily a reduction of latency, if that makes sense.
Yep. So like you said, for my real-time applications, like a VoIP call, like a Zoom meeting, a Teams call, WAN smoothing is going to achieve the goal there. But for a buffered video or non-real-time content, like you said, you can sacrifice latency a little bit as long as your jitter is good and your bandwidth is good. And so two different tools for two different applications, ultimately.
Exactly. So WAN smoothing versus forward error correction, kind of like see a little pretty picture here, and Peplink has this nice guide here. WAN smoothing does have levels. So you have normal, medium, and high. Normal is going to be, will be at most 2x of the original data traffic. Medium is going to be 3x the original data traffic. High is going to be 4x the original data traffic. And then maximum is going to be based on the number of WAN. So it's going to create literally a duplicate packet per WAN. So in Adam video where he had 101 WANs, if he had maximum, he'd have 101 duplicated packets, which that would be excessive in my opinion, but definitely funny to watch. Where forward error correction is going to use 13% or 26, so it's low and high. So it's going to use 13% of additional overhead or 26% of additional overhead, adding those parity bits to the redundance to the streams. So giving you, like I said, packet loss reduction, jitter reduction, but not necessarily latency reduction.
So like in my case right now, I've got 3 WANs. I've got a T-Mobile and a Verizon and a second Verizon connection. But I've got my WAN smoothing for this call set to 2x. So right now, it's just using one Verizon and one T-Mobile. If one of those two goes down, I've got the third there that'll stream in and start sharing some of that payload, but I'm not using overhead across all of those WANs, so I've still got more bandwidth on top of that too, right? I've got the benefits of WAN smoothing, but I've also got this extra capacity on that third link because ultimately I don't need that much duplication in my environment. I'm not moving, I'm not in an unpredictable scenario. Things are pretty straightforward here. But again, depending on who you are and where you are and what you're doing, you may need that extra overhead to really make sure things work as smooth as possible.
And so then Peplink said, hey, well, actually, I can't say Peplink said, hey, customers said, hey, I like forward error correction for broadcast, but we need maximum bandwidth possible because we're uploading large video streams and things like that. And so they said forward error correction is great, but we don't always have packet loss. Is there a way to have adaptive packet loss prevention? So add a little extra overhead when there's detected packet loss, but if I'm getting 0 packet loss, don't charge me 13 or 26% overhead. So in 8.5, firmware, Peplink introduced adaptive forward error correction. And so basically it'll use somewhere between 6.7 and 20% of extra overhead, depending on the amount of packet loss that's occurring. This is a great way to maximize bandwidth while reducing the overhead of forward error correction if you don't need it. But when you do need it, it's there to kick into action and mitigate that packet loss. And this just shows Peplink's continued dedication to making the mission always accomplished. They're constantly evolving based on customer scenarios and requests to make sure that we're going to get the best possible solution or bonded environment based on the internet we have. And then that, I'd add in there, Peplink is not an ISP. They're a technology, a software and hardware solution. And so all we can do is take the ISPs and the carriers and make sure we can use them the most efficiently as possible. And so, we're just trying to adapt based on data plans, based on packet loss, latency, signal strength, jitter and overhead, internet availability, failures and uptime. And so what we're trying to do is, Travis said it the best during the first summit. You're like, all we're trying to do is get as many nines as possible. We're not going to get 100%. We're going to get 99.999999. And it's like the more internet connections we have with high availability routers, it's more nines. And so we're just increasing that likelihood that we're going to have a good result by combining those internet connections together and then creating solutions that adapt to the environment that these Peplinks are being deployed in.
One really cool thing about this adaptive forward error correction too is it's super intelligent at the link level. And so, previously you had to set this, fixed level of overhead, and that applied to all of your links. Well, usually you only have one link at a time that's really causing problems or having problems, right? And, you've usually got one or two good links and maybe one or two bad links. And our dynamic FAC, we look at this at every single path level. So if you've got a mobile router with 4 links and you're talking to a data center that has 2 links, there might only be a problem on a path from this one link over here to this one link at the data center. So we're only going to increase the overhead on that single path because the other paths are fine. We don't need to use that overhead there. And so it's just highly efficient and very, very granular in how we evaluate each of those paths and where we need to protect them more. So again, you're just getting the absolute most out of those links without, sending a whole bunch of extra gigs through when you don't really need to sometimes.
Exactly. And then, so we take these technologies, bonding, smoothing, FEC or adaptive FEC, and then you say, well, I have scenarios where I might need to use all of those. I want to be able to transmit files as fast as possible. I want to be able to do Microsoft Teams or Zoom meetings with WAN smoothing, and then I want to be able to stream or broadcast. Well, Peplink supports subtunnels. Subtunnels allows you to create 5, that's a test question, 5 subtunnels for every SpeedFusion connection. That means that you could have a subtunnel that has hot failover from fiber to broadband or fiber to bonded Starlink or fiber to bonded 5G. So you could have one fiber line that's your gig by gig circuit, and then you can hot failover to bonded 5G or Starlink. You can have a tunnel that uses WAN smoothing. You can have a subtunnel that uses FEC or adaptive FEC. And then you can create outbound policies that says if the destination is Microsoft Teams or Zoom, use WAN smoothing. If the destination is my YouTube RTMP server, use adaptive FEC. If the destination is my remote site or just the internet, YouTube and Netflix and Office 365, use bandwidth bonding, because I don't care if there's a little bit of latency or packet loss on an HTTPS stream, because it's gonna mitigate that. Those TCP streams are gonna handle that just fine. They're designed to handle those limitations. So I want as much bandwidth as possible going out to the internet, but I want to make sure that my Teams meetings and my Zoom meetings are smooth and perfect and resilient. And so you can actually create subtunnels and then use outbound policies to drive traffic to each of those tunnels.
Yeah, and that's really important because different applications have different needs, right? Like we can have gigabit cable internet at our house, but our Zoom and Teams meetings still have poor quality, right? Zoom and Teams doesn't need more speed. They need more consistency. And so we're able to map those applications to the appropriate subtunnel policy so that you get what you need for each application on your network.
Exactly. And Peplink, this is a lot of information, and we get asked a lot of questions about SpeedFusion. So Peplink put together a SpeedFusion white paper working with partners and enthusiasts around the world. That collaboration is the SpeedFusion white paper, and it's going to be available at peplink.com/brochure-download. When that comes online, you'll be able to access that. So if you're a Peplink partner and you're trying to demonstrate the value of SpeedFusion to your customers, this is going to be a great resource for you to be able to hand out and show all the stuff that goes into SpeedFusion and WAN smoothing, forward error correction, adaptive forward error correction, subtunnels, things like that. We're going to have that in this SpeedFusion white paper.
Yeah, this is kind of like our resume, right? Like we've talked about all these different things that makes Peplink SpeedFusion bonding better than anybody else out there, and this white paper is really going to put some words to that and help you communicate what all the differences are in SpeedFusion. Because again, there's lots of people that say they do bonding, but bonding isn't bonding. Everybody does it differently, and the results vary tremendously. And that's again why we're able to win in so many scenarios where somebody else's bonding wasn't up to the task. And so that white paper is really going to get into the nitty-gritty of what the differences are and talk in detail about a lot of the things that we've talked about here, but again, in a digestible format that you can provide to your customers, partners, customers.
Exactly. And if you're a Peplink partner or an end user and you want to learn more about Peplink technologies and integrating them, please join us at the Peplink Tech Summit. This year it's going to be in November in the Hilton Orlando Convention Center. And so we're going to have sales training for your sales team, Peplink certified associate training for your tier 1 and tier 2 techs, and then Peplink certified engineer training, brand new. I mean, actually writing that content right now. Peplink certified engineer training. Travis and I are going to be hosting the PCE. Agent Adam and Captain Nick from Europe and New Zealand are going to be hosting the PCA, and John Grote and my own Tim Swayze are going to be running the PCSS, the Peplink sales. So throwing that out there, join us at the Peplink Tech Summit this year. And we actually have some time for Q&A, and there's a lot of questions. And I wanted to skip those last slides because there are a lot of really good questions. And so I'm going to go through some of them. If I don't get to your question, please feel free to email, Peter@westnetworks.com or Travis@peplink.com, and we can answer those questions for you. But I am going to go through some of these for you. One person asked, what if I have a circuit that's 200 megabits per second with another circuit that's 100 megabits per second? What's the theoretical bonding speed fusion or speed throughput? So that's going to be 300 megabits per second minus 18% overhead of speed fusion. So just round that to 20. That's going to be 60 megabits. So you'll be at 240 megabits of total throughput. So like 245-ish megabits per second. So you're going to have an 18% overhead for speed fusion. And then if you use WAN smoothing, that's either 100, 200, 300, right? So you're going to have overhead on top of that. So if you're doing forward error correction, it's 18, and then forward error correction is going to overhead 13 or 26%. And those are really good things to know when you're running your calculations. Also, Peplink has a tool built into our hardware called WAN Analyzer. The WAN Analyzer, you can actually run non-bonded tests between all of your circuits and your head-end unit to make sure that, hey, I'm getting 250 megabits of throughput minus my bonding overhead or minus my forward error correction overhead, minus my WAN smoothing overhead. This is my expected capacity.
Yeah, that WAN analyzer tool is really important because a lot of the times we see people say like, hey, look, I'm getting this much speed on speedtest.net. Well, speedtest.net is not where you're sending your application to, right? You're sending your application to a server on some other side. And so the WAN analyzer evaluates that exact path and what the just native throughput is outside of any tunnel or bonding. And then you can compare that more accurately to what a bonded performance looks like.
So I have a webinar about Peplink and Starlink with SpeedFusion. David asked a question about Starlink and Peplink and cellular. One thing to be aware of with Starlink and bonding is there are some higher than normal packet loss when you're talking about real-time protocols over Starlink, most likely due to the LEO nature. We are working to constantly working to improve that. But with packet loss, it's important to enable either WAN smoothing or forward error correction when you're using Starlink. So you'll actually see better bonded throughput on a forward error correction link. And thank you, Martin Langrid from Europe for discovering this a couple months ago. But you'll find better capacity with forward error correction enabled than even if you just do bonding by itself. So Starlink, if you're using Starlink, try forward error correction to mitigate packet loss, which actually seems to help in some scenarios increase throughput as well.
Yeah, you're going to very typically see about 1% packet loss on a good Starlink connection. And that's, like Peter said, that's just the nature of Starlink and LEO. And so right there's room for improvement that Peplink's able to help and mitigate some of those experiences. For some enterprise users, that 1% isn't acceptable. And so SpeedFusion is there to help smooth that out and provide a better experience.
We don't, this, someone asked if we're going to do detailed SpeedFusion bonding. We already have SpeedFusion bonding detailed webinar. And so if you go back to Peplink University SpeedFusion, we actually go over configuring SpeedFusion. This is really to talk about the technologies and kind of debunk some of the myths around it. But we have another Peplink University SpeedFusion webinar that goes over the actual settings. Yeah, so Ricardo, you said, to be clear, if we have 250 meg circuits, 100 megs of total throughput, you should see around 82 megabits, right? 82 megabits of usable throughput. David asked if you can use WANs, if you can use smoothing, can you select which connections are allowed to participate in smoothing? And the answer is yes. In SpeedFusion profile settings, you can actually choose which WANs are utilized. And so when you choose the WANs, like you could create a subtunnel for smoothing, then only select particular WANs that you want to be involved in smoothing. And that goes into, I mean, like literally it's a multi-hour conversation about configuring SpeedFusion. It's why we have the PCA and PCE training, because there's a lot that goes into SpeedFusion, more than we can do in a single 1 hour webinar. But you can fine tune a lot of settings inside SpeedFusion, like latency cutoff, which WANs are being used for upload and download, so symmetry. You can also do which WANs are used in a particular profile. We talked about you can have 5 profiles. Well, you can have a profile that's just 2 internet connections with hot failover. You can have another profile that is just cellular connections. You have another profile that's just Starlink. You have another profile that's all of them together. And so you can choose the WANs, choose how those WANs are used, choose latency cutoff. Hey, if you have a latency specific application that needs it to be under 93 milliseconds of latency, you can cut off the WANs that exceed 93 milliseconds. And that way you're not adding extra overhead where you don't need it to be, because your mission requires 93 milliseconds. And so you can actually, you can actually set up internet connections based on, or set up SpeedFusion profiles based on your needs. And so those are all going to be in your advanced settings. Highly recommend going through the PCA training, watching the SpeedFusion video, or set up a meeting and we can answer those questions directly. For FEC, overhead is either 13 or 26%. Adaptive FEC is 6 to 20%. Measure aggregate bandwidth. Currently, adaptive FEC is only configured on local profiles. If you're using the beta version of InControl, it's available, and then you should see that get pushed out to Earth and Mars here soon. So adaptive FEC will become a drop down where you have FEC low and high. You'll then have adaptive as an option. It's currently available. Let's see if I have my. So in InControl, if I go to my SpeedFusion fleet and SpeedFusion configuration, edit, there's my 2 servers, there's all my tunnels. And so right there, forward error correction, adaptive. So you'll have disabled, low, high, and adaptive. This is in kind of the beta version of InControl for testing. This should come to GA here very soon, probably in the next release. Just see if there's any other. There's a lot of questions, and some of these are really good and just not able to answer in the amount of time that we have. So once again, if I'm not answering your question, please feel free to email us, Travis@peplink.com, Peter@westnetworks.com, and we can answer Somebody asked why I call hot failover a bonding method. Because it is. You need bonding in order to hot failover. The idea of hot failover is session persistence. So in other words, you have sessions going over fiber, and then you want to move that to a cable modem or a broadband circuit without dropping the session. You need to encapsulate that in SpeedFusion. But if that fiber's 2 milliseconds gigabit, and then you have a broadband circuit that is 500 by 35 with 13 milliseconds, you're better off doing hot failover instead of bonding. So you can do hot failover, which says priority, use the fiber connection. And then only if that fiber connection fails, do I want you to move that data over to the broadband circuit. Because if I've got a gig by gig, 2 millisecond latency internet connection, I don't want to slow that down to 13 milliseconds for an extra 35 megs of upload. And then, minus overhead, you're actually going to lose that anyways. So hot failover is a bonding technology. It's part of SpeedFusion that allows you to maintain session persistence regardless of this, while ensuring that your primary circuit stays online as a priority. Bonding Starlink is tricky. There's a lot of considerations. Somebody, anonymous attendee, said, when combining Starlink WANs, I try to tell people bonding is kind of weird with Starlink. 1 + 1 does not equal 2. 1 + 1 equals a really, really good 1. And then you need to have that third and fourth one and fifth to actually see benefit of bonding Starlink on a regular basis. There's congestion, node congestion. There's packet loss and latency issues that go into bonding Starlink, where you need to create stability first by using FEC and 2 Starlinks. And then what you want to do is that third and fourth and fifth Starlink. Those are going to start to see bandwidth improvements that you would see on a normal basis. A lot of times with Starlink, what we recommend actually is load balancing your Starlinks and then bonding with WAN smoothing or FEC for voice and video applications to reduce that jitter and latency. But once you get to 3, 4, 5, and we've bonded 40 Starlinks together, and we're seeing incredible throughput. We've seen upwards of almost 4 gigabits of throughput bonding Starlink. It does work. You just have to, it needs to be placed properly. You need to have a powerful enough router to accomplish it. And then you need to make sure that you're understanding that Starlink does have packet loss issues. And so we just need to make sure we address that. The summit is in person in Orlando, peplinkTechSummit.com. I think we're going to do a little live stream, sneak live stream of bonding 10 Starlinks together is one of the things that we're going to be doing, as well as some T-Mobile bonding. But most of the summit will be in person only at this stage of it. And there are still a lot of questions. So I just want to say, if I did not answer your question, please feel free to email Travis and myself. I know Travis has been typing like crazy, answering questions in the background as well. He's smiling. But yeah, I mean, the idea is that WAN smoothing or SpeedFusion is not just IPsec wrapped in an LACP or a traditional what's currently being used out there in the world. WAN smoothing is built from the ground up. It has 18 years of experience, and we have multiple bonding algorithms to solve different application challenges. And so if you have a weird challenge, have a weird application, and the traditional bonding technologies aren't working for you, I highly advise taking a look at SpeedFusion and understanding how our application uniqueness allows us to solve more challenges than others might be able to might not be able to solve, I guess. But anyways, thank you so much, Travis. Once again, thank you for hosting like you do. And I'm looking forward to meeting you in person down again down at the summit here in November, which is just a month away. So the next summit, the next webinar will be at well, it might be after the summit actually, but yeah, join us at the Peplink Tech Summit and meet everybody and come hang out and learn and look at all the new toys and yeah, and plus, Florida weather in November, it's going to be gorgeous. So come join us.
I think the summit, anybody who's like questioning SpeedFusion, skeptical, not sure if it's going to work for what they're doing, go to the summit and talk to the people that are using it. You will talk to so many end users from such big name companies that you never even had a clue were using Peplink, that we can't say are using Peplink, but seeing is believing, and talking over and over again. People have tried to do these things with so many other vendors and they land on Peplink because it works and it does something different. And that summit is going to be the best testimony to what the power of Peplink really is. So get your butts over there and go talk to the people that are using it already. I'll end with that. Thanks,
Couldn't
Peter.
have said it better. So we'll sign off. Thank you so much. Have a great day and enjoy. And if you're in Florida, if you need help, let us know. We're also in Florida. I know that hurricane's coming through, so yeah, we've got Starlinks in stock. We got Peplinks in stock. So if you're in Florida and you're affected over the next couple days, please reach out. Let us know if we can help you out.